Sorry, and Grace, you have breaking news where you are.
Kuala Lumpur
Now, a line of severe
sekitar Muar dilanda banjir kilat.
Assalamualaikum warahmatullahi wabarakatuh from Sekolah Menengah Sains TENGKU FARIS PETRA. Flood is one of the most natural disaster that continuously haunting us, even though many effort has been put to make a stop to this particular problem. Our team had developed a mechanism to prevent this happening. And now, introducing the instant flood wall.
Flood is classified as one of the most important parts in hydrology studies and is very significant in civil engineering research. For the past couple of years, frequent unexpected floods which occurred in every part of the world had caused tragical loss in terms of human lives and also commercial properties. As a deterrent to this particular issue, the usage of sandbags has been introduced, but it is not as effective as it should be. Therefore, an alternative mechanism known as the instant flood wall is developed to keep the flood water away from getting into the buildings.
The main purpose of this project is to overcome the disadvantage of the sandbags usage. For example, a high amount of money is needed to build each flood barrier because sandbags will be used in a large amount. Secondly, the sandbags are not able to block the water from entering the aimed areas because they can easily be broken down. And lastly, the sandbags can cause pollution because the sand inserted will be able to flow with the water into the environment during heavy flood.
Firstly, we want to create a design of flood wall which is applying the concept of hydrostatic force. Next, we want to fabricate a lab-scale model to stimulate the instant flood wall system. The third one and the last one is we want to make a better science-based product for flood wall to substitute the old style which is using sandbag.
So we will conduct the procedure by carrying out the design of the instant flood wall and decide on the size and the scale of the model. Moving on, we will prepare the materials to build this prototype. Then, we will fabricate the prototype according to the design plan. Next, we will implant the flowing tubes at the below level of the ground. After that, we will attach the wall with an underground float and put it in front of the target area. Then, we will install stoppers at the same level of the ground. And finally, we will test the prototype with water to see its outcome.
So now, let's take a look how this project works.
When the water in certain area rises to the danger level, the water will flow into the underground tubes. Since the position of the underground flowing tubes are positioned from a higher level to the lower level, the great gravitational potential energy of water will be converted into high kinetic energy. Thus, water will flow through the tubes with a high velocity. As the space under the flood wall is continuously filled with water, the pressure of water in the space will increase. Then a great hydrostatic force exerted at the bottom of part of the wall make it rise quickly. The wall, which attached with an additional part which designed according to the buoyancy concept, decreases its weight and thus the wall rise smoothly.
Experiments have been conducted to test the effectiveness of the instant flood wall. This kind of process is to investigate the relationship between the height of water level and the rising of the flood wall. We try to put a different volume of water to see whether the flood wall will rise up according to the flow of the water. It shows that when the water reaches the danger level, it is channeled by the underground flowing tubes. After that, the water fills the area under the wall, which already attached with the float. The wall is successfully operating instantly when the water is continuously filling the area. Then, the smooth movement of water is obtained. As the conclusion, the movement of the wall is directly proportional to the movement of the water under the flow. This invention should be commercialized to the professional engineers outside there because it is beneficial not only to the people but also to the buildings for the agriculture and also to the engineering world. As a justification, the project will save the money used to protect the aimed areas. Second, the flood wall will become a permanent protection compared to temporarily flood barriers which uses the sandbags. And third, it is also more effective as it will rise up according to the speed of the water which converted into high hydrostatic force and based on the pressure exerted under the wall.
So, we can conclude that the float wall operates instantly due to the hydrostatic force exerted under the foot of the wall. Next, a simple design of a large-scale instant float wall really proved its effectiveness. The third one, this project will help in blocking the water from rising up in an area. The last one, do not worry about the cost but do worry about the effect after the flood.